This video is going to conclude section 3.2 on addition of whole numbers, and the part that we had left off on was the computational estimation. Toward the very end, we had taken a look at mental mathematics and talked about the fact that computational estimation allows us to do mental mathematics more easily, but it doesn't give us exact answers. It actually gives us approximations. So our first example of this is going to be one that you may or may not have seen. It's called front-end estimation with adjustment, and that phrase with adjustment is really important. But let's start with the front-end estimation part. So front-end estimation means taking each of our values, keeping only the first value, so like the 3, and then zero everything else out. So 332 becomes 300, 462 becomes 400, and 225 becomes 200. And if we add all of these together, we get 900. So that's front-end estimation. Adjustment does not do the same thing with sort of the leftovers, right? There's a 32, a 62, and a 25, the back pieces of these that we didn't deal with. Adjustment means taking them and looking at what's approximately compatible numbers. So you might notice that these two right here, 32 and 62, they're awfully close to compatible numbers. Again, not perfect, 35 and 65 would be perhaps, or 30 and 70 or whatever, but they're close. So these two approximately are 100, and then of course we've got the 25 at the end. So we're going to add these three pieces of information, 900, 100, 25. And if we do that, we get 1025 as a approximation using this method of estimation. Another one is grouping to nice numbers. So I kind of used this idea in the last one. Again, we're not looking for perfect compatible numbers, but for approximately the same. So these two are approximately compatible. They're about 40 and 60, so this would be about 100. 35 and 70, those are approximately 100. If you wish, you could make that 55 and a 50. That would be a reasonable assumption, or you can just leave it as 55. So the estimation right here is that we have about 255 or 250, whichever which would make you feel better. Clustering happens when numbers are all really close to the same value to begin with. So you might notice these particular values. They're all about 500, right? So they're all approximately 500. So a way to estimate when we have that property happening is to simply say that this is approximately 500 times our number of numbers, which in this case is 5. So this is approximately 2500 for the sum. Rounding is something that we're all pretty familiar with. On this particular one that I'm giving you, I wanted to show you a couple of ways that you could do with rounding. If you're told how to round, then you have to use rounding the way you're told. So let's say you were told that you were rounding to the thousandths place. So the way rounding works is that you use the thousandths place as your starting point, and the value to the right determines whether the value rounds up from 4,789 to 5,000 or down from 4,789 to 4,000. So the number 4 itself will either stay a 4 or it will become a 5. Those are the only options. Since the number here is a 7, we're going to round up because 47 is closer to 50 than it is to 40. That's the basic idea. In general, what we do is if the number after the term we're trying to round to, or the place we're trying to round to, is 5 and up, we round up. And if it's 4 and down, we round down. So this 4789 will become 5,000. And then the 3,148 will become 3,000 because the number after the 3 was a 1. So we would round this down to 3,000. So rounding to the nearest thousands, it's about 8,000. But let's say maybe that we were supposed to round to the hundreds, right? The nearest hundreds. So in this case, we're going to use our 7 and our 1 as our reference point. So it's either going to stay 4,700 or it's going to go up to 4,800. And again, we determine it by the number after that place value. Because it's an 8, it's going to round up. So this would be 4,800. The next one, this is a 4 after the 1, right? So since it's 4 and down, we'll round down. So this will be 3,100. 4,800 plus 3,100 is 7,900. And of course, we would expect that these answers would be very close together, at least pretty close, right? 8,000, 7,900, pretty close together. If you're not told how you have to round to the hundreds, round to the thousands, it's kind of your pick. But you need to pick a place value. Like, let's say, for instance, that some of your numbers are in the thousands and some of them are in the hundreds and some of them are in the tens, right? You have to actually decide to round them all to the same place value. Like, everything's rounded to the nearest hundred. You can't sort of pick and choose, oh, this number I'm going to round to the nearest tens and this one I'm going to round to the nearest hundreds. You got to pick one and go with it. Our last example of approximation or computational estimation is actually called using the range. I'm sure you've heard the word range before, and it means lots of things. Here we're using it in the phrase, or in the description of it means a range of values. So what we're going to do is we're going to take our two values and we're going to round them both up. We're going to take the two values and we're going to round them both down. So let me show you. We'll do the rounding down first. We're going to take each of our values, so 370, and make it 300. And then 647 and make it 600. So the lower estimate here, by rounding them both down, would be 900. And then if we had an upper or a higher estimate, we would round them both up. So 370 would become 400, and 647 would become 700. 400 and 700 would make 1100. So our range of values is always a range that it's lying between. So it's not a specific one value answer, but it's between 900 to 1100.